Good morning, everybody. Myself, Raghubir Singh, lecturer in civil engineering from Pandit Jagatram, Government Polytechnic Colleges, Sharpur. Today, in this session of railway bridges and tunnels, we are going to have a talk on very interesting topic of bridge foundations. Let's have a look what are the contents of today's lecture. We will start up with the definition of bridge foundations. What are bridge foundations? Then what are the functions of bridge foundations? And then some study regarding the various types of bridge foundations. What are the different types? And what is their utility or their suitability? In these types, we will have a look on main 4 different types of bridge foundations, like the spread foundations, the raft foundations, pile foundations, and lastly regarding the well foundations. However, we have some more types of bridge foundations also, but we will concentrate on these 4: the spread type, the raft one, pile foundations, and the well foundations. Starting with the definition of bridge foundations. What are bridge foundations? The parts of the bridge directly in contact with the subsoil supporting the superstructure of the bridge are called bridge foundations. So basically, it's a part of substructure, we should say, supporting the superstructure. On the substructure part, we have piers and abutments. So the abutments, piers, and other lowest artificially built parts of the bridge, these are included in these bridge foundations. Now, regarding the functions of these, the very first function of bridge foundations is to distribute the load of the superstructure. Of course, the substructure part also, the abutments, piers, over a larger bearing area, so as to bring the intensity of load within the safe bearing capacity of the soil. As we all know that during the designing of a building or the bridges, bearing capacity of the soil plays a very important role. So, to distribute the load of the whole bridge, the superstructure part, as well as the part of the substructure, abutments and piers, we want to distribute that particular load to a larger area so that it is within the safe bearing capacity of the soil, and bridge foundations plays a very vital role in bringing the intensity of load within the safe bearing capacity of the soil. It's distributing the load. Secondly, the bridge foundations prevent the tilting and overturning of the abutments and piers provided in the bridge. Now, we all know that these abutments and piers are the base of the superstructure. The superstructure is it's on these 2 abutments and piers, and the tilting of these abutments and piers leads to the damage of the whole structure. So, to prevent this tilting or the overturning of the abutments and piers, we require the bridge foundations. Thirdly, to provide the overall stability to the bridge, we need the bridge foundations. And last but not the least, to prevent the unequal settlement of the subsoil and the bridge superstructure. Once again, this is very important, and it is also concerned with the bearing capacity of the soil also. The unequal settlement leads to the failure of the structure, and since these bridge foundations distribute the load over the larger area, so basically these foundations are preventing this unequal settlement of the subsoil which is beneath this whole bridge and the bridge superstructure. So these are the 4 different functions of the bridge foundations: distributing the load, preventing the tilting and overturning of the abutments and piers, providing the overall stability to the bridge, and lastly preventing the unequal settlement of the subsoil and the bridge superstructure. Now coming to the types of bridge foundations, we have many types of bridge foundations like the spread foundations, raft foundations, pile foundations, well foundations, and lastly the caisson foundations or the box caisson foundations. So these are 5 different types, but today in this session of presentation we will discuss the first 4 the spread, raft, pile and well foundations one by one. Moving to the first one, the spread foundations. Now what are these? The foundations constructed in open excavations by increasing the area at the base of the structure. The foundations constructed in the open excavations by increasing the area at the base of the structures by means of offsets. So we are providing offsets at the base, increasing the area. So such foundations are called spread foundations. We will see a diagram also. We will get a very clear idea from that diagram how offsets are provided or how the area is increasing at the base. Now these foundations are also called open foundations. Why? Because these are constructed in open trenches. Now just have a look on this diagram. Here this is the offset part, and you can consider this column or this as a pier or abutment. So basically the load of this particular pier, it is distributing over a larger area. So this type of foundation can be called as the spread foundation, and in this particular diagram, if this sees the bearing capacity of the subsoil and this P is the load acting on this pier, so it is spreaded over a larger area. So this particular area is indicating the foundation part. So this is, you must have got the idea of the spread foundations, how these foundations looks like. Something more regarding these foundations. These spread foundations, it is a shallow type of land foundation. It's not very deep, and it is practicable for a maximum depth of about 5 meters. Means we have, if we are going from 15 to 20 feet below the ground level, so up to that much depth, these foundations are viable. These are practicable. We can provide these spread foundations for a maximum depth of about 5 meters. Also, this type of foundation is very much suitable for the bridges of moderate height. Now, in the last session of bridges, in the classification of bridges, you must have seen different type of bridges, the major ones, the minor ones, suspension bridges, and many more. In those bridges, the bridges which are of moderate height, or you can say the minor bridges, those bridges can be provided with this type of spread foundations. Or in other words, I should say that these foundations are not very much suitable for very heavy bridges. We opt other type of foundations for heavy loads, for heavy structures of bridges. So this type of foundation is suitable for the bridges of moderate height, to be built on dry ground. Means we have got the ground dry in this case. Now something more regarding its suitability. These foundations are best suited in situations where hard soil is available. Now this is again important. Spread foundations are not meant for the soft soils. These are best suited in the situations where hard soil is available, and that also within the 1.5 meters to 3.5 meters below the bed level of the watercourse. Watercourse means it may be a river. So, below the bed level of the river from 1.5 to 3.5 meters, and with the hard soil, these spread foundations are the best. So, these are the three different conditions. We need a hard soil, a limited depth, and these foundations are the best for the moderate heights of bridges. Something more regarding it. Spread foundations are also best suited where scouring is minimum. Now, this is a new term, scouring. I would like to define this term, what exactly the scouring is. Actually, scouring is the process of cutting or deepening of the river bed. With the continuous flow of water, there are two types of erosions, I should say, one on the horizontal side, one on the vertical side. So, this scouring is the process of cutting or deepening of the river. It is towards the vertical plane, cutting or the deepening of the river bed due to the action of water. So, it is called scouring. And let us have a look on the difference between the erosion and scouring. Erosion is the horizontal widening of the river, whereas this scouring is the vertical deepening of the river bed. The river can be eroded in both ways, horizontally also and vertically also. So, if it is in the horizontal plane, if it is the horizontal widening of the river, it is called erosion, and if it is the vertical deepening of the river bed, then that is called scouring, as I have just mentioned. And these spread foundations are best suited where the scouring is minimum, means where the river is not deepening vertically. It's on the other side, I should say, where the scouring is maximum, these are not suitable. So, this is regarding the spread foundations. Now, let us have a look on this diagram. This is a diagram showing some reinforcement part. It is incomplete spread foundations, but you must have got an idea, like this is a wider area, and this is the reinforcement of, maybe it may be of a pier or an abutment. It is of a pier, and you can see the wider area of the spread foundations. Now, after this it is casted with the concrete, and we will get a solid spread foundation after the casting. So, this diagram also is also giving you an idea how the area is enlarged at the base. So, this is the spread foundation. Now, coming to the raft foundations. Now, what exactly is the raft foundation? The foundations consisting of a thick RCC slab covering the entire area beneath the bridge, supporting all the piers and abutments, or it is a single large slab. In spread foundations, it's in the we have small slabs, but in raft foundations, it consists of a thick RCC slab covering the entire area beneath means below the bridge, supporting all the piers and abutments. So, such type of foundations can be termed as raft foundation or mat foundation. Raft and mat, these are one and the same thing, raft foundations or the mat foundations. Once again, these foundations are also of the shallow type. These are not the deep foundations. So, spread and raft both are considered as the shallow type of foundations, and the raft may be composed of a thick solid RCC slab, or there is another option also, or there is a second option of RCC T beams with the relative thin slab. So, we have two options for the raft: one, a thick solid RCC slab, or there is a second option of RCC T beams with the relative thin slab. Now, how this looks like? Look at this diagram. Now these are the T-beams, as you can see, inverted T-beams, and this is the thickness of the raft foundation. This is the second case of the raft foundations. As I have mentioned here, the second option of RCC T-beams with the relative thin slab underneath. So you can see here, these are number of T-beams, 1, 2, 3 and 4 beams, and below these beams the thickness is this much. This is the thickness of the slab. This is the thickness. So this diagram is also giving you an idea of the raft foundations. Now these are the piers of bridges. This is the superstructure part of the bridge, highest flood level. This is the river bed, and this foundation is below the river bed up to a height of 5 to 7 meters, and these are the 4 T-beams with the slab having this much thickness, and it is the base part, lime concrete. Now look at this. This is the first case. The first one, the RCC with a uniform thickness. It is under construction. As you can see, they are laying the reinforcement part, and no T-beams are provided here. It is a large raft with the number of columns. So this is a raft foundation. The constructed raft foundation looks like this particular diagram. This is a large mat foundation or a raft foundation having this much thickness. Now in this particular case, you must be watching that there is no T-beam. So this is the first case, the raft foundation with the uniform thickness. So you must have got some idea how it looks like, the raft foundation. So you can provide a number of piers or columns here. So this is all regarding your mat or the raft foundations. Regarding its suitability, where these raft foundations are more suitable. Now this type of bridge foundation is suitable when the bed of the river course consists of soft clay and silt. Now this is how it is differing from spread foundations. In the case of spread foundations, we have hard soil, we require the hard soil, but here these are very much suitable where the bed of the water course or bed of the river, it consists of soft clay and silt, and the hard soil is not available within the reasonable depth. So we can say the raft foundations are best suited for the soft clay and silt base, and where we are not having the hard strata, hard soil. And if we are not getting the hard soil up to this much depth below the river bed, these are the best foundations. We can provide raft foundations if it is of soft clay and silt bed. Secondly, these are best suited in the situations where the allowable bearing capacity of the soil is low. The second suitability of raft foundations, whenever the allowable bearing capacity of the soil is on the lower side, the best option to provide the bridge foundations whenever the depth is up to 5 or 6 meters, raft foundations are the best option, the second suitability. Thirdly, these are also very suitable when the bridge loads are heavy, the third part. And once again, comparing it with the spread foundations, as I have told you that spread foundations are meant for the moderate type of bridges which are not very heavy, not carrying heavy loads. But the raft foundations can be provided on the soft soils having low bearing capacity, and also with having heavy bridge loads where the bridge loads are very heavy. So these are very suitable in such cases. You must be, we are comparing the previous one and this raft foundation also, that how their suitability is differing, the spread foundations and the raft foundations. Both are shallow foundations, but these are the major differences between the spread one and the raft foundations. Coming to the third one, Now we are moving to the deep foundations, pile foundations, well foundations. These are the deep foundations. The firstly regarding the pile foundations, what are these? The foundation constructed on the piles is known as pile foundation. The definition is very simple, but this process of piling is comparatively, it is very tedious. Let's have a look on this particular term, piles. Now what is a pile? Before studying this pile foundation, I would like to concentrate on this term, pile. What is a pile? A pile is an element of construction which is driven vertically in general. In general, it is driven vertically deep into the ground to increase the bearing capacity of the soil. Piles are increasing the bearing capacity of the soil and to take up the load of the structure. After watching the diagrams, you will get a more clear idea how these piling is done and how they are increasing the bearing capacity of the soil. So basically, these are the elements, piles are the elements of construction. These are driven vertically or sometimes inclined also. Most of the time, these are driven vertically in the ground to increase the bearing capacity of the soil and to take up the load of the structure. Now we have variety of piles. Piles can be a friction pile. These are the types of piles basically. The friction piles, the bearing piles, the batter pile or a guide pile according to its use, how we are using that pile. So these are having different names, friction and bearing. In these, I would like to concentrate on these two, which are very common, the friction piles and the bearing piles. Something more regarding pile foundations before moving to the friction pile. You can have a look on this diagram. These are the number of piles, steel piles. These are constructed of steel material. Now, according to the material of construction, piles can again be classified as concrete piles, metal piles, maybe of steel, or a timber or wooden pile. Wooden piles are also there. So it all depends that how situation demands, what type of pile is opted in which situation. So it is best suited, the pile foundations are best suited where heavy scouring of river bed is expected. Now once again, this is how this is different from spread foundations. Especially I have told you the spread foundations are meant where the scouring is minimum, whereas pile foundations are best suited where the heavy scouring of river bed is expected. Means the river is going to scour or erode in the vertical directions. So this is regarding the general definition of pile foundation. Let's look at this diagram. In this diagram, it is under construction. The piles, these are of the steel. Now how these looks like, let's have a look on all these piles. There are a number of piles here. These are steel piles. Now we will look on the bearing piles and the friction piles one by one. Firstly, the bearing piles. What are these? The piles which rest on the hard strata, the piles which rest on the hard strata, it may be rock, and act as a column to bear the load of the structure are called bearing piles. Now what these piles are doing, these are actually bearing the whole of the load coming on it. Now this is a concrete bed, and basically if you concentrate on this diagram, above this concrete bed we are going to erect the piers or abutments, and these piles are inserted in the soil, and these are deepened till the hard strata. These are the piles and this is the concrete bed. The whole of the load is coming all these piles. These piles are bearing that load, that's why these are called bearing piles. Now these piles bear vertical loads and transfer the load of the structure to the hard stratum lying underneath. We have discussed that these piles are bearing this load, and of course the loads of the piers coming over it and transferring it to this hard strata below. Now look at this diagram. this is you will get a more clear idea of the bearing piles. The load is coming over this pile. Now, this is a reinforced concrete pile of RCC, in situ reinforced, constructed at the site, and this is a timber pile. There is a different in the shade also, it will give you the differentiation. This is the RCC pile, this is a timber pile or a wooden pile, I should say, and of course, the ground reaction is acting upwards. This is a firm soil, or I should say hard strata. This is the hard strata, and the load is coming over it. And what these piles are doing, this yellow part is indicating the soil. It is the penetrable soil where these piles are penetrated. So, basically this load coming over these piles, these are transferred from these piles to this whole hard strata. Moving to the second type of piles, the friction piles. Now, these piles, the piles which do not rest on the hard strata. Now, this is important, there is no hard strata here. Friction piles are not concerned with the hard strata. So, where these are suitable, now these are the piles which do not rest on the hard strata and bear the loads on account of their frictional resistance between the outer surface, this is the outer surface of pile, and the soil in contact. These dots are the soil through which this pile is penetrated. So, there must be a friction whenever you deepen this pile, there is a friction between this soil and the outer surface of this pile. So, there is a frictional resistance. So, such type of piles which are deepened by the frictional resistance between the soil and the pile, such type of piles are called friction piles, because the frictional forces are the prime forces acting here. Secondly, these are used where the soil is soft. Once again, a very important thing to note it down, that these friction piles, these are used when the soil is soft and no hard strata is available up to considerable depth. Now, this is the basic difference between the bearing pile and the friction pile. Bearing piles are provided only when there is a hard strata underneath, whereas the friction piles are provided in the soft soil and when there is no hard strata available up to the considerable depth. Look at this. Now, these are the again example of timber pile and in situ reinforced pile, and there is a skin friction between this soil and this particular pile. Once again, look at this. This arrow is indicating the skin friction between this pile and this soil. The load is coming over it, and this pile is able to bear this load only due to this skin friction. There is no hard strata here, no hard strata over this timber pile, as well as no hard strata here beneath the RCC pile. So, you must have got the difference between the friction piles and the bearing piles. These are without hard strata at the base, whereas the bearing piles are having hard strata underneath. Now, you must be very curious to know that what is the method of construction of pile foundation, how pile foundation is done. For constructing a pile foundation, piles are driven to a hard base if it is available at a reasonable depth below the river bed. Now, if it is a bearing pile, then these piles are driven to a hard base. Now, how these are driven, I will tell you in the coming slides, how pile is driven deep into the ground. Secondly, the spacing of the piles is kept 1 to 1.2 meters according to the magnitude and distribution of the load to be carried. There is not any strict spacing, it may be from 1 to 1.2 meters. Something more regarding its materials, piles can be of RCC or the steel piles, these are very common. It may be timber piles also. RCC and steel piles are generally used for the bridge foundations. So, this is regarding the method of construction of pile foundation. After driving the piles to the required depth, when we get the hard strata, when the pile is driven up to that depth, a common platform consisting of RCC slab of design thickness is provided to cover the heads of the piles. When we have provided number of piles, we will cover the head of the piles by a common platform. As we have seen in the diagram also, we provide the common platform, and masonry or concrete work of the pier